Alright, as promised, I was going to solve this problem right here. Find the instructions said find the nth term. So I was going to do that for you right here. I have not done this problem before. I do not know the answer, so I'm going to work through it and try to explain to you what I'm thinking the whole way through. When I'm done, I'm going to go ahead and find like the, I don't know, the 12th and 50th terms also, because a lot of times they ask you to do that. So the first thing I do is I write which term it is right on top. It just helps me keep everything organized. And so I create this little table. Now I do the difference, so 6 and 10 and 14, and I hope that's 18 because these go up by 4, so I just added 4 there. Now it doesn't ask me to find the 6th term, but I could, because you see how the second difference is up by 4 every time? 6 plus 4 is 10, right? So on. So this would be 22. So to find the 6th term, I would just have to add these. 6th term should be 69. All right? Didn't ask me to do that, but sometimes they do. So this right here is what I refer to as the first difference. It's not constant. That means it's not linear. Like the nth term is not linear. The rule isn't linear. If this was the same every time, the same number every time, then whatever number it was would be the leading coefficient of the nth term. Now, this is called the second change, and it is constant. It's constant. It's 4 every time. So the way that you find your leading coefficient is you take this second term, or the second, the change of the second, and you divide by 2. So we're going to have 2 as our leading coefficient. So part of my rule is going to be 2n squared. Now maybe that's my answer right away. I don't know. So I'm just going to check, because maybe that's what it is. So if I plug in 1 squared is 1 times 2 is 2. That's not negative 1. That doesn't work. That's not it. And so now I got to do a little bit more work. All right. If this was a 6 instead of a 4, then it would be 3n squared. All right. So next thing I'm going to do, I'm going to rewrite a table. Here's n. Here's what my sequence is: negative 1, 5, 15, 29, and 47. Now, 2n squared is what I have to start with. What I'm going to do is I'm just going to write out what 2n squared is whenever n equals these numbers. I'm going to write it right here. And see if I can figure out what to add or subtract to this to find the formula that gives me these outputs. Okay? So plug in a 1, I get 2. I'm going to 2, I get 8. 2 squared is 4, times 2 is 8. So 9 times 2 is 18. 16 times 2 is 32. And 25 times 2 is 50. Now, I have to look. I need this number to be that number. So I have to add or subtract something to this. It looks like if I were to subtract 3 from this, I would get that. In fact, that's what it looks like every time. And it is. So that's what I have to do. I have to take this and subtract 3. There's my nth. There's my nth term. All right. So since that's my nth term, if I wanted to find the 12th term, I would plug in 12 for n and do all this. So 144 times 2 minus 3 is 285. That would be the 12th term. The 50th term, I would just plug it in, so it would be 2 times 50 squared minus 3. So 50 squared equals times 2 equals minus 3 equals 49.97. So anyway, this is what I got for my nth term, which is what your homework said to do. And hope that helped.